Let's say we are in a hypothetical situation in a tropical climate where we aim to plant albizia. And by default, 1,111 trees are being planted per hectare. And this corresponds to a planting distance and a row width of 3 by 3 meter. We submit. And the first thing we check is the limiting factors. Is something off, but everything seems to be alright? And then we check the plot cover and we see by year 6 the plot is completely covered by the albizia. Now what will happen when we change the planting density? So let's say we only plant 200 of them and we plant them very dense. So the planting distance and the row width is 2 by 2. And I'm adding this to the suffix so we can see it in the title. Now we plant an additional 200 trees, but these we give a lot of space. So let's say 4 by 4. And now you can see that the trees that are planted very densely only take up 8%, while the trees that have been given a lot of space almost take 32%. Now let's try it with even more space. Let's say 6 by 6. Now we see that even though they have been planted with a lot of space, they don't take up that much space. And this can be explained by the fact that the natural crown maximum diameter is only 3 meters. So there is a limit to which it can take up space because of the maximum crown diameter. If we would change this to 4, and let's do it like this, we see that it takes up a lot of space because the crown diameter has been increased. Now we remove this one again. The difference in the cover taken up by the trees with different planting densities can also be observed in the biomass produced. Even though the number of trees is the same, the biomass produced is a lot more for the trees that have been planted with a lot more space in between. And this then translates to the carbon removed per species, and you can see that it is more for the trees that have been planted with more space in between. Another situation can be an intercropping scenario. So let's say we intercrop the albizia with an acacia, and the acacia is actually growing in layer 4, while the albizia is growing in layer 7, which is an important detail. So here we have 3 by 3, and for the acacia it's the same. And both of them, they get 550 trees. Here you can see the cover and the consequent biomass produced. And as I said, with the different layer, you can see the height of the trees, and the acacia is below the albizia. If we are playing again with the planting densities, let's start with the acacia. We change it to 4 by 4, and let's see what happens. Basically nothing. But if we change the planting density of the albizia, you can see that the albizia is taking over, And even though the plot is used more efficiently, the acacia is limited in its space. And this has its consequence for the biomass production of the acacia. Now,